Okay, so next group is Kent, Sam, and Aaron. They get the award for the stickiest fingers because they like to steal stuff from the lab. I'm kidding about that. They used an enormous amount of hot glue in their project. So you'll see what their project looks like, but it was pretty much held together by hot glue alone.
Alright, hi guys, my name is Kent Tsai.
I'm Aaron Lee.
And I'm Sam Chu. And we worked on engineering a multi-jointed robotic apparatus to assist the recovery of objects, which is pretty much just a robotic arm. We nicknamed the project Project Aura, just to be easier. It stands for Object Retrieving. And we use servos and a few potentiometers and Aaron talk about.
Okay, so our main goal for this project was really to retrieve objects accurately and efficiently using only servos in an Arduino Uno. And also, we needed to have the arm itself be able to support itself when it's moving, doing dynamic movements. And also, we needed the potentiometers to be accurate and actually be accurate in controlling each different servo. So next, let me show the code. This is our sample code. Right here is when we start initializing each different servo and actually attaching it to each pin on the actual Arduino. Up here, you can't see it, but each of these are actually variables from the Arduino to attach it to each pin. And then here's our main function, the loop function. And what it does is it initializes a variable called val, or value, and then it will read the value of the potentiometer pin, which is the potentiometer is a little knob that you can control, the user can control. And it'll actually just read that straight value. It's from zero, the value is between 0 and 1023. And it'll actually, right here, the map function, it will convert it into value between 0 and 179, which is a value that the actual servo, the servo motor, can use. And then right here is just where the servo actually just writes or moves according to whatever the potentiometer value is.
So how we built it, we used a total of 6 servos, 4 micro servos. There are 3 in each of the fingers, and there was 1 in the wrist joint. And we used micro servos just because they were smaller and we didn't need as much power. And we used a full size in the elbow joint, which moves everything up and down. And then a full size in the base, which can let the entire arm move if you want to pick stuff up, like on your left and right. And each servo is plugged into our Arduino board on the PWM digital input, which lets the computer communicate with it. And then each of our potentiometers is how you control the robot. So we have a little like control console where you can twist each knob and that'll move each joint. And those are plugged into analog inputs. And this is just a little drawing of our circuit. These are the servos plugged into the board through the potentiometers. And that's a picture of what it looks like. It's picking up an Easter egg in that picture. And you can see like these arms are over.
So while building a robot, we had very limited resources. Our entire robot's made out of possible sticks, foam board, and hot glue. So it was very expensive. And basically the fingers work. There's 2 fingers in the front that are curved inward and they pinch the object. And the third one's like a spoon and they work together to create the object. On the bottom right, there's a cat model that we made and here's ended up. And we faced many challenges while making this robot. First of all, the third finger. When we made the third finger, it weighed differently compared to the other 2. So it would move faster and then it would knock the object out before the 2 could pinch it. And then we just fixed that by just shortening it. And then we also had problems with the elbow joint because the hand was too heavy for the elbow joint to carry the entire weight. So we had to add a counterweight. And then we also had insufficient power supply because we were running 6 servo motors at the same time. And we fixed that by adding like 16 batteries. And then overall, the structural integrity and stability was kind of off because as you can see, certain components are attached only on the right side, and it wasn't like stabilized with the axle. so it was really shaky when we were controlling it. But we fixed that in the code by adding averages, so it would take the average from the reading, from the log, and then it would jump up and down. And then even though our robot is amazing, we still did it by having stronger materials such as 80-20 or high-powered torque motors. And this will lead to cleaner design and a stronger and more stable robot. We also want an option for autonomous functionality. So when you press a button, it'll be able to detect an object with the infrared sensor, and then it'll be able to move the motors in the right way to pick up the object without any human effort.
Oh, and then we'd like to thank our teacher fellow, our professors, and our cluster assistants. So thank you. And then